Hello everyone, my name is Hassan Sherwani and welcome to our webinar on accelerating ML2O pipeline for production using Databricks. In this webinar, we shall discuss a tool called MLflow and how it could help data scientists, data engineers, and business team to work in unified managed system, something like a ecosystem to create value for its customer. MLflow is an open source platform for managing end-to-end machine learning lifecycle and is gaining a lot of attention in data science community for past few years. Databricks has recently revised its version as and introduced us with MLflow 2.0. Therefore, we shall walk you through key features of this update in this session. So let me set agenda for this webinar. First, we will introduce ourselves, our team Royal Cyber. Then we would talk about machine learning and its different life cycle. What could be possible challenges in this life cycles and how would we create a pipeline for machine learning? Then we would discuss briefly about Databricks and MLflow. We have a case study for you where we will express our demo. We will solve a problem together and we will implement MLflow. So let's start with myself. My name is Hassan Sherwani. As I expressed, I am working as head of data analytics department at Royal Cyber. About myself, I love experimenting with different models and their optimization algorithms. However, it was a bit surprised to see how these models never see that level of production value as they deserve due to lack of understanding of machine learning workflow and differences in experiment and production phase. So this urged me to extend my knowledge. At Royal Cyber, we are working on end-to-end machine learning project approach that is from data collection to application working in production. And this gives me a lot of satisfaction seeing a real value for data science project. So this is about me. I have my colleague Mehroz Alam with me. Mehroz, would you like to introduce yourself?
Yeah, sure. Thank you. My name is Miroz Alam. I have been working as a data scientist for more than 5 years. I have worked on different data science projects. In Royal Cyber, my routine job is to find insight from the data, create end-to-end ML pipelines, then deploy it on cloud.
Thank you, Mehroz. Moving forward, something about Royal Cyber. So we are a company of around 1,800 members, 10 plus location around the globe. We have very strong cloud practice, somewhere around 250 cloud experts. Most of them are certified. We keep diverse cloud portfolio in terms of certifications such as AWS, GCP, Azure, and IBM. We have also a very large open source practice where we work with open source tool set to solve machine learning challenges where we can actually help you out. If you want to know more details about us, please shoot out an email to us and we'll love to tell you more about our solutions. So about machine learning and its life cycle. So machine learning is type of an artificial intelligence. That is a word that academics love to use that allows a software application to become more accurate at predicting outcomes without being explicitly programmed to do so. Machine learning algorithms use historical data as an input to predict new output values. And when we talk about pipelines, so machine learning pipeline is an end-to-end construct that orchestrates the flow of data into an output from a machine learning model that is a set of multiple models. It includes raw data as an input, its feature, and then of course an output. The machine learning models and machine learning model parameters become another essential part of it. And finally, there is a predicted output. So if I kind of simplify this process, we have an input that is raw data. We create different features of it. And then we have a model. We implement that model, we tune our model, and finally, out of that model, we predict an output. So hence becomes this overall machine learning pipeline. Let me walk you through this again in form of different steps. First step is we gather our data. We prepare this data. Mostly it is called, this process is called exploratory data analysis. Data wrangling is about taking care of different steps in data. For example, we might have missing values, duplicate values, anomalous values. So we take care of those values according to our requirement. Then we analyze our data. At this stage, we try to visualize different formats and pattern in our data. Finally, we train our model and then we test our model, how well that model has performed. And finally, once we have done this training and testing part, we deploy our model into production. So this is overall system. You can imagine that there are a couple of feedback loops. We tend to get back to from training our model to going back to data preparation part. And this happens a lot because it's not a very static process. It's a very dynamic model process. So some of the challenges that we face on day to day with our machine learning pipeline. So number one challenge is that data scientists need to write code over and over again. And because of that, they have to make different experiments. And there is a lack of a system where they can keep a ledger of their experiments. So this is very important in knowing what they did last time. So after a month, if they are coming back with the new data and implement a new model, they should know what happened last time, which parameters worked and which failed. Similarly, there is a problem in difficulty in reproducing this working code. So there are different versions in, for example, open source tools like Python, and there are different libraries. There was a TensorFlow, and then there was an update in TensorFlow 2.0. So because of that update, when we want to replicate this code on other side, maybe on client side, we might actually get a couple of errors, or we even get different results on other side. So that is another challenge. Then we don't have enough packaging and deployment power in machine learning pipeline. And the reason being that we don't have standard tools. So some organization tend to use one type of a tool and one type of tools as best practices, and then other organization has a different set of tools. And because of this mismatching, when we tend to talk in different teams, they might be familiar with different tools. So because of that, we actually have very different understanding, and project could become really, really complicated. Finally, we don't have proper protocols for our central storage for managed model. That is, how would we take care of our models? In old days, we used to use configuration files. Then we started using different methods to serialize our model, that is of pickle files. And later on, now we have somewhat evolved, and we are using more sophisticated method. What methods we are using in MLflow, I would explain you, because MLflow is a tool which would actually take care of all these four underlying serious problem. So I would say that first two problems are hardcore data science problem. This one is much more of ML ops, and then this one is actually more of data science and overall project problem. And all of them are taken care of MLflow. So before I jump to MLflow, let me talk about Databricks, because that is something that I am speaking a lot. So what is Databricks? So Databricks is developed by creators of Apache Spark. It is a web-based platform, which is also a one-stop product for all data science requirements like storage and analysis. Databricks is integrated with Microsoft Azure, AWS, and GCP, making it easy for businesses to manage a huge amount of data and carry out machine learning tasks. So it provides CPU and GPU environment for analytics. Finally, it deciphers the complexities of processing data for data scientists and data engineers, which allows them to develop machine learning applications using R, Scala, Python, or SQL interfaces in Apache Spark. So over here, we see different layers of our architecture. So for example, if we talk about this lowest layer where we have different type of our data, for example, structured, semi-structured, and unstructured data. And over there we have Delta Lake. And Delta Lake is nothing but a storage layer that helps data lakes to be more reliable. Delta Lake integrates streaming and batch data processing while provide ACID. By ACID, I mean autonomicity, consistency, isolation, and durability. And not only that, but it scales this metadata handling as well. Coming to Delta Engine, it is a query engine that is optimized for efficiency, processing, data stored, and finally, it has other inbuilt tools that support data scientists, such as BI reporting, and we can see MLflow is also on top of it. So let's talk about MLflow. So MLflow actually consists of four components. So number one component is related to our uh, model tracking. So tracking is all about, it has APIs and user interface components that records data about machine learning experiments and permit queries. It supports Python various APIs like REST, Java API, and R API. Main components of our record are source, our code version, parameters, artifacts, start and end time, and finally matrices by which we would evaluate our models. Coming to second important aspect or component of MLflow is MLflow projects. So it does package data science code in reproducible and reusable way according to convention. So projects component comes with an API, command line tools designed for running projects. Features ensure projects change into ML workflow, and it's interesting that we have also some properties specification for our project. So we might have name, our environment, and our entry points. Finally, we could come to MLflow models. So MLflow models, as name suggests, it package format and tool permits easy deployment of model. So it could be in batch and real-time data. So we could use platforms such as Docker, Apache Spark, Azure ML, and AWS SageMaker. And it permits add metadata to MLflow models. So over here, we play with models. There are two main components. One component is called model signature. Second is called model input example. So there are different parameters inside that model that needs to be updated and evaluated. And based on those parameters, we would analyze which model is most suitable model. Finally, we have registry. So as I said, that registry actually store or serialize our model into a central repository. It provides API and user interface for our centrally managed models and their life cycle. In registry provides model lineage, model versioning, annotation, and stage transition. And we'll get to know about them more when we would go into our demo. But just to an overview is model tracking is all about when data science implement different experiments. Machine learning projects are all about packaging this code in a format that could be reproduced. Models is all about deployment of model and taking care of its parameter. And registry is about serializing our model in a central repository so that it's very much transparent for the whole team. In MLflow, we have two options. We can serialize our model into pickle, or we can also use register ID. So talking about MLflow 2.0, which is an added version of MLflow and is recently introduced from by Databricks. So there are a couple of key points, and I would rather say improvements in this version. So number one improvement is it provides pipeline.yaml files. So YAML files are mostly acted as configuration file, and again, it's much more easy for those who are familiar with DevOps environment. Secondly, it provides a search experiment API, which is a great feature for data scientist and data engineer because it provides tags and names. Uh, Third, it has definitely improved the Spark model logging. Finally, it has provided this model URI option, and this is much more to add like those who love to work with Docker images in old system and to create one model serving image. It has actually added a lot of value for those who have been coming from DevOps background, have worked with Kubernetes, and so all those tools like Docker, Kubernetes, which are coming from another domain, are now facilitated also in this domain, which has provided us an extra edge. As I said, that there are different domains which are overlapping over here, and it is becoming more and more standardized, so which is always positive. So over here, we will implement a case study. We would use New York taxi fare prediction dataset, which is freely available on Kaggle. We would actually use total fare amount as our target variable. We would perform different data processing practices in this demo, but our main focus is actually to highlight how we would take care of our models. So we have implemented decision tree regressor model, and we would show you how you can keep track of different experiments with different parameters of decision tree. Finally, we have used our different matrices to validate our models. Those of you who are not very familiar with them, you can Google them and you would get a crispy idea of what they are. Finally, we would implement this whole machine learning pipeline by using MLflow, taking care of all of its four components. So something about our dataset, a very quick view of it. Fair amount is our target variable. Other variables are pickup date time, drop off date time, trip distance, zip code for pickup and drop off zip, pickup day of week, pickup hours, trip duration in minutes. We will explain you during this demo.
All right, it's time for a live demo. As we have already covered the data, we will start from the Databricks repo option. So you can see that I have cloned this template name as MLP regression template, and it's a main branch. So you can see there is all these important files, but before that, please review this readme file, because it contains all the necessary steps that are required to run this template on your local system as well on cloud. So let's talk about the notebooks. When we work on notebook, we feel like we are working on our comfort zone. So MLflow provide us this facility, like when we work on the Databricks platform, we can use this Databricks notebook. And when we work on locally, so we can use this Jupyter notebook. We know that when we talk about the notebooks, it is for development process. But when we talk about the codify the pipeline process, we cannot put notebook on this critical path. So the actual pipeline configurations come into pipeline.yaml file. So and when we talk about the profile database.yaml file, it contains all the steps to override this pipeline.yaml file. We will see this database.yaml file a while. So let's start from pipeline.yaml file. So when we talk about the machine learning life cycle. So what are the basic components that we required? First one is dataset, and the second one is predicted column when we talk about the supervised learning. And the third one is all the methods that are required to process the data and evaluate the model results. So all this configuration and steps are defined here. So you can see that in data part, here is a location where from where the data is coming from and the data set format. And we can ingest or get data from delta tables. So here is our target column, and the remaining is all the steps like is when we divide the data into train, test, and validate. Then we transform the data. After that, we train our model. Then we will evaluate our model results. And here is all the standard matrices like root mean square error, mean absolute error, and weighted mean square error. And even you can add your custom own matrices if you want. You can see here the option. Here is the option. So now let's look on database.yaml file. We have seen in this pipeline.yaml file, there is a couple of variables are defined. The reason for that in Databricks, you might have a bigger data set to that from where you work with. That is something you can override here. Like I have pasted the path of the DBFS data. Then I have defined the format. So let's run this notebook and and see what all these steps are. So I have already run this command. So is install are the necessary libraries that are required to run this template. So let's start from here. I'm just running the pipeline profile equal to Databricks. So you can see that the pipeline is created successfully. So let's run the second command p.clean. So this clean command is just ensure that everything is created successfully and there is nothing cache in the pipelines. So let's run this inspect command. So this command is show the overall flow of this MLflow template. Like here it is ingesting the data, then it is splitting the data into train, validate, and test. Then the data is divide. Then the data feeding to transformer to transform the data. Then the model is training. After after the model is trained, so model will pass to the evaluating part where the model performance will be evaluated and the model will be registered that have a very good accuracy. So now we will see the ingest command. Let's run it. So and ingest command is just ingest all the data and do some basic EDA. It will do the some basic EDA. So we can see here. First of all, we see the data schema. Here you can see all the variables, the features that are exist in our data set. Like on the left side, you can see there are pickup date time, drop off time, trip distance, fare amount, pickup zip, drop off zip. And on the right side, all the data types are defined of each feature. So let's drive more in the data set. So we can see the overview here. We have number of 6 variables. There are 2 date time and the 4 are numeric. And their total size of the memory is 856.8 KBs. And here you can see all the variables like pickup date time, drop off time, and trip distance, minimum, maximum value, distinct values, missing values, fare amount, pickup zip. Seems everything is all features are reasonable. But one thing that I've noticed anomaly here is fare amount. So here is the minimum negative add value, negative $8. So I wonder what happened here. Is it seems like A cab driver give money back to the customer. Probably there is something noisy. So we need to do something. So maybe it happened that customer book a cab and driver wait for the customer. When the customer comes, they did some discussion and it's end up in a very bad way, means the customer cancel the ride. So there is a 0% distance covered and the consumption of fuel is wasted. So we will try to uh, avoid these anomalies. So let's run the split command. So first of all, talk about what are the function of the split command. It will divide the data into three parts: train, test, and validate. Train data set is used for processing, training the data, for train the data. Validate data is used for hyperparameter tune of the model, and the test model data set is used for the model performance. So let's review this split.py file. So you can see that after splitting the data, here we have applied some more pre-processing. As we have seen, there are negative red dollar value. So we have just developed, created some kind of filter. So we will neglect those rows that contain negative values and that contains zero distance covered. After that, we have created some more columns like pick a, pick up day of week, pick up hours, and trip duration. So reason for you developing this trip duration, let's say if you are sitting in the cab, there is a lot of traffic. We will expect that the meter will keep going up. So there are some features that will probably be useful. So let's back to our file. So you can see that the split file command is divide the data into three part: train, validate, and test. And it is also added all the new features that we have developed that I have showed in the split.py file. So now we will run the transform command. While it is running, so we will look in the transform.py file. So you can see that we have applied one out encoder in pickup hours and pickup day of week. And we applied standard scalar to normalize two features. First one is trip distance and the second one is trip duration. As I understand, trip distance and duration are very important feature for this our current problem. Let's see the transformer structure. So as I've showed you in the file, you can see all these steps here. One out encoder is applied on pickup hours and pickup day of week. And standard scalar is applied on trip distance and trip duration. Here is the input schema that is feed to this transformer component. On the left side, you can see all these features. And after transformation, here is the output of this transformers pipeline. So you can see it is converted into multiple features. So all these features will be passed to the train component. So let's start to run this train component. While the model is training, let's look on the train.py file. So you can see that I have developed two methods that are using one model, random forecast for decision tree regressor, but the parameters are different. Like you can see tree estimator parameter 1, tree estimator parameters 2. So I just set the parameter 1. So let's run. Let's see the model result, then we think more and analyze more. So this model is giving us the very good result: 3.63 training error rate and 3.86 validation error rate. So let's first we run the evaluate part more. So you can see that model evaluation part is completed. You can see the validation score and the test scores. And we can also see here the feature importance like trip distance, trip duration. So now we will change the model. So you can see that I've just changed the function. So now we run it again. Now we will see the model results. It is one of the best thing in here in MLflow. So you can see that I just changed the model and we don't need to rerun all this pipeline. It will just we need to the main component that is related with our problem. Like I just want to change this trend part, so I just changes on this specific part. So we can see that this model result is not too well. You can see that there is a training error is 0.006 and the validation is 3.22224. So I think this model is overfitting. So it's mean our the first model is quite better. So let's see the leaderboard. So this is one of the best thing that I have noticed here because let's say we have 40 to 50 data scientists are working on different models. So at the end, we have too many models. So this leaderboard box will show which one are the best model. So this is the this is provided us the best model and also provided the run ID. You can see here. So we can extract this model from this run ID. And here we have seen the feature importance. So now let's see and compare the model results. So we just move to the Databricks tab and we compare these models. So on the below side, we can see there are different parameters that I have applied on decision tree regressor. And here is the parallel coordinate plot. Let me change it. Let me change the error rate matrix. So you can see here I have created Poisson, max depth is none, and I've selected means sample split is 2. So we got this error is 2.5. Similarly, I just for the second decision tree regressor, I have used MSE and max depth is 5 and minimum sample split is 4. So I got this error a little bit high, 3.06. So let's move to the model. So here we can see on the left side, it's artifacts where we can see all the pre-processing steps and all the evaluation metrics and also a model. All this stuff are here. And on the right side, for we can see for make prediction, we can use this snippet code for Spark data frame, and for pandas we can use this one. Let's say let's say this model is quite better. I want to use for production. So what should I do? I just register the model. I just put the name. So the model will be registered. So you can see model registered. So just I will click on this part. So on the so here we can see that after registration, we convert this model into none to any stage. Like I want to convert this to staging stage. So for best practice, it is better we always put the model into staging stage first, because in the staging stage, the quality insurance and some more product related people can test the model. If model is perfect, so we can move to this staging stage model to production. So just for our saving our time, I have already deployed a model in staging stage. So let me show you. So here you can see the our model is in staging stage. Just we need, and we can get the API if we want to work on locally, or we can put it here overall instance for production. You can see that it is working. It is giving the results. And if you want to use for your front end website, or if you want to hook with somewhere else, so you just need to convert it to staging stage into deployment, and you can use anywhere whenever you want. I hope everything is clear.
Thank you, Mehroz. Indeed, a very, very valuable demo. I myself learned a couple of new things from this. Hopeful audience had also learned something new out of it. This is our webinar offer for those who have attended this. We could actually have a kickstart with you, and we could assess your business problem. It would be a 3 hour session, which would include your assessment report and our recommendation based on your problem statement. So if you have already implemented Databricks in your organization and you want to understand more about problems like MLflow or Delta Lake, or if you would like to migrate from your old system towards Databricks, we could definitely help you out in this session, and it's free for you. So consultation is free, of course, and afterwards we would see whether we would like to go ahead with a POC or not. So finally, we would start taking some Q&A, and I would pause for a minute to check our screen.